All right, here are the key ideas having to do with the previous lesson. In the previous lesson, we sorted information to create a frequency, Italian frequency table, and then to create a histogram, which is also a bar graph, and a frequency polygon, which is also a line graph. So here's lots of the key ideas having to do with that and to organize the information. So the first key idea here is just the fact that large sets of data can be, and generally are, difficult to interpret unless they're organized. So organizing data into intervals and determining the frequency of the data, so once you have intervals, determining how often or how many values go into those intervals can make it easier to interpret and draw conclusions. So organizing data is very useful, in other words. Next, a frequency distribution table is a set of intervals of equal width. So they have to have an equal width, so if you decide that your intervals are going to be going up by 5s, or in this example, like 450s, continue with that equal width pattern. Each interval is associated with a frequency. So you'd see how many values go in each interval. That indicates the number of measurements in the interval. Next, a frequency distribution should have between, and this is just for visual reasons and just for organizing well, between 5 and 12 intervals, which organizes the data best. To determine the interval width, here's what you would do. You would first of all determine the range of the data, so do the highest minus the lowest. You would then divide the range by however many intervals you would like to have, so by the number of intervals. Next, you would adjust to a suitable width. Okay, so that can tell you or give you an idea of what your interval width should be. Next, each interval begins just after, and you'll see where this is useful in just a second, just after the first value in the interval. This ensures each value is only counted once. So here's a good example. If you have intervals of 0 and 5, and 5 and 10, you'll notice that both interval has the number 5 in it. The value 5 would actually go in the lower interval, okay? Because technically, when we're sorting this 5 to 10 interval actually starts just after 5. So 0 to 5, it would go into that interval, a data value of 5. All right, just the end of the key ideas here. A histogram is a bar graph. It's just another name for bar graph. The intervals are marked on the horizontal axis, so the left to right axis, and the frequencies are marked on the vertical axis. The horizontal and vertical axes must meet at 0, and if the scale on either axis is not consistent, you must include a break. And what you'll notice here is that right here that I'm circling in red, there's a break because the scale isn't consistent at first. It goes from 0 to 150 and then consistently goes up by 450. So that is not a consistent part of the axis. The last key idea here is a frequency polygon is a line graph of a frequency distribution produced by joining the midpoints of the intervals with straight lines. The values on the horizontal axis can represent the midpoints of the intervals, but they do not have to. Okay, they're especially helpful, so line graphs are especially helpful for comparing, and here's an important thing because it's harder to do this with bar graphs for comparing multiple sets of data because they can be graphed on top of each other. And what you should do is use either different colors or different symbols if you're doing a multi-layered line graph, such as this one. So it's very useful for showing multiple data. And that's the end of the lesson. If you're in my class, what you might want to do is try the following question and get me to look it over. You will be sorting information and then creating a bar graph.